Okay, good morning, guys. Sorry I couldn't be here, although I probably was just here. Um, but today what we're going to do is we are starting a new unit. This new unit is called Data and Probability. We are going to start out with the probability part of this. There is only one kind of general category of question that they ask on the Keystone when they're talking about probability, and it's called compound probability. In all of your questions, you're going to do more than one thing. So when you look at example one here, it says Tressa is going to spin the spinner to the right 2 times. So she's going to take this spinner and spin it not just once, but twice, which means that when she's spun the spinner, there's going to be 2 colors. Maybe she's spun a brown and then on her second spin, she got an orange. Maybe she got a pink and then a brown. So, when they start asking the questions, we're going to be asking about what's the probability of getting these 2 colors in this example. The way we're going to do this for our first introductory lesson is we are just going to make a list or a table that shows every single thing that could happen when Tressa spins that spinner twice. This is really similar to what you guys do in biology class when you do Punnett squares. So this should be a little bit familiar. Basically, what we're going to do is we're going to make a table. And on each side of the table is going to represent one of the 2 spins. So for our, we're going to start over here on the left, and that's going to be our first spin. And when she spins this spinner, she could get one of these 3 brown spaces, which we'll write as B, B, B. So the first brown space, the second brown space, the third brown space. I usually number those, so I'll do B1, B2, B3. Or she could get one of these 2 orange spaces. So I'll label those O1 and O2. And then finally, she could get that last pink space, which I'm just going to label as P1. So the number's there to remind us why there's 3 of them. There are 3 brown spaces. Now, most of our questions involve us doing the same thing twice, so we're just going to rewrite that same list across the top of our table. B1, B2, B3, O1, O2, and P1. And now to fill in our table, we are just going to cross those 2 things. So in the upper left-hand corner, this means getting the same brown space twice. This represents also getting 2 brown spaces, just you rolled and you got them in a different way. And we'll write BB here. Once we get past the B's at the top, our next space represents getting a brown on the first spin, but an orange on the second spin. And here's another way for that to happen. And last but not least, there is one way in this row to get a brown and then a pink. Now, because we have B in the next 2 rows, the next 2 rows of our table are going to be the same. They are just different ways of getting these same results. Repeat that row, and I'll repeat that row one more time. Yeah. So we filled in our table with all the different things that could happen if you spin a brown on the first spin. And our next 2 rows are going to be what happens when you get an orange on the second spin. So I'm going to start with my O, and I'm going to end up writing OB in this first space. OB, OB, OO, OO, OP. And I'm just going to repeat that line because the next line does also represent an orange on the first spin. OB, 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 OO, OO, OP. And then our last line will represent getting a P on the first spin. So we've got PB, PO, and PP to end us off here. Okay, so once we have that table filled in, we can use that table to solve some simple probability questions. We took something that was compound, doing 2 things, and since we've listed it out, we just know now one list of everything that can happen, and that's called simple probability. So our first question is, what's the probability of getting a brown and then a pink? So the way this is worded, we do care about that order. We want a brown on our first spin and a pink on our second spin. And the only spot that I see that in the table is those 1, 2, 3 different ways right there. There are 3 because there are 3 different ways to get that first brown. Then you were kind of locked in on getting that pink. So that answer, probability is just a fraction. We found 3 things out of our table was 6 by 6. So we will write 3 out of 36. Use your calculator to simplify that. Put in the fraction 3/36, and the calculator will give you back 1/12. Right. Next question wants us to know what the probability of getting orange and then another orange are. So we look for a pair of 2 O's in our table, and we find that this little square here with 4 different things in it represents getting an orange and then an orange. So this probability is 4 out of 36. Again, your calculator can simplify that and give you 1/9. Our last question here, what's the probability of getting 2 matching colors? So this one's a little bit less specific. The other ones told you exactly what you wanted to look for in the table, but here we're describing it. 2 matching colors can be any of the 3 colors as long as they're a match. So we have these 9 different ways to get 2 browns. We have the 4 oranges we talked about in the last problem. And we have this one lonely pair of pinks down here. When we count how many different things we have just shaded, we have 9 blue blues plus 4 9 blue blues plus 4 OOs plus 1 double P. And that gives me 9 plus 4 plus 1, which is 14 out of 36. So we'll write 14 out of 36. Again, the calculator will simplify that one, and that's 7 out of 18. So you can always use a table like this to solve a probability question. Depending on how many different things that can happen, kind of tells you about the size of your table. So this example was nice because I could kind of do the table in a reasonable amount of time. If my spinner had like 30 spaces on it, this might get a little bit tougher to do because you'd end up with a really, really large table. But for today's examples, we'll keep them small so the table works. Okay. We're going to do one more example, and something different is going to happen in this one. In example 2, it says there are 6 tiles in a bag numbered 1 through 6. And we are going to pick 2 tiles from our bag, but the key here is we're not replacing the first tile. This is kind of taking some of our possibilities away. If I'm picking 2 tiles and not replacing the first one, that means there's no way for me to pick 2 tiles and have them both be the same number. There are 6 tiles and they're all numbered differently. So there's no way for me to get 2 ones. So let's take a look at this. We're actually going to draw up 2 tables here. One just based on the situation, and then one to help us answer our questions at the bottom. So in this case, we have 6 tiles. They're labeled 1, 2, 3, 4, 5, 6. We're going to pick those same tiles across the top. Now, normally, if you're doing a problem this way, just look at your questions and either draw one table or the other. Our first table is going to match what we did in example 1, but our second table is really going to match what we have to answer in these questions. So same idea as the last one. I'm going to do 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Okay, those aren't the numbers 11, 12, 13, and 14. That represents your first pick and your second pick. A 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4. I'll keep filling my table in. These ones will start with 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, and so on. You can fill your table in with me. So there's our table, but remember what I said at the beginning. We are picking these tiles without replacement, which means that some of those things we wrote in our table cannot happen. And those things are spots where you've picked the exact same tile twice. So watch what I'm going to do next here to solve that. They all show up in a really easy spot. 1, 1 can't happen. 2, 2 can't happen. 3, 3 can't happen. So I'm crossing out things that really can't happen in my situation here. And as long as you set your table up so that you write the things in the same order down the side as you do the top, you're always going to be crossing out the main diagonal of your table. So there aren't 36 different things that could happen like there were in the last problem. There's only 30 different things that could happen because I've crossed out 6 of them. Okay, so now looking at our next set of problems, you'll notice that they all say what's the probability of some sort of sum. I want to add those two numbers up together. So a different way to look at this table is to start out the same way. But instead of listing out each individual thing, actually add up the numbers. So I'm going to leave my X in the top row. And now I'm going to look at these numbers. And instead of writing 1, 2, 1, 3, I'm just going to add those numbers up. This should be 3. This should be 4. This should be 5. So I just count over 3, 4, 5, 6, 7. Gets a little tricky with the X's, but I have a 3, an X, and a 5. So it would have normally been 3, 4, 5, but it's 3x5. So we'll do 3, x, 5, 6, 7, 8. My next row should start with 4. So I'm going to go ahead and write 4. I'm going to count up, but there's an X here where the 6 would be, 7, 8, 9. So it still counts normal, 4, 5, 6. It's just that that 6 got an X. Okay, so the way this table goes is it counts up across, it counts up down. So with that, I can keep on filling this table out. I'm going to start this row off with 5, 6, 7, but I get an X where the 8 should be, 9, 10. My next row should start with 6, 7, 8, 9, X, where the 10 should be, 11. And my last row starts with 7, 8, 9, 10, 11, and has an X there. So two tables that express the exact same information. You never need to draw both of these. Use your answers, or use your questions to decide which one to draw. It's really this stuff that's telling me I want to draw this table rather than this table. So anyway, now for the easy part, actually solving the questions. For the first one, I want to know what the probability is of getting a sum of 9. So I'm going to look for all of the 9s in my table. There are 4 of them, which makes my answer 4, not out of 36, because those X's don't count, but 4 out of 30, which will simplify to 2/15. All right. The next probability is what's the probability of getting an odd sum. So this time I'm going to highlight all the odd numbers, which there are a lot of in this table, but they do kind of follow a pattern. You're actually almost like a checkerboard here, covering up half the numbers here. So I've actually covered up 3 in each row in 6 rows. So that's actually going to be 18 if I count those all up, out of the same denominator, 30. So 18 out of 30 is going to give me, when I use my calculator, 3/5. There we go. And then last but not least, what's the probability of getting a sum greater than 5? There are 2 ways to do this. You can highlight all of the numbers that are greater than 5. So starting with the 6s, we've got those 4, these 6, these 4. the 4 9s, 2 10s, and 2 11s. That's a lot of numbers highlighted, but it looks like I have 1, 2, 3, 4, 10, 14, 18, 20, 22 out of 30. Like I said, there was another way that you could have done this. If I had just highlighted 22 out of 30, which let me give you the simplified version, I actually could have just figured out how many I wasn't going to highlight. So just an alternate way to do this, I could have said, well, if I've got to get all the numbers that are bigger than 5, then that means I'm leaving out these numbers I'm circling here in purple, and there are 8 of them. So if I'm doing all but 8 of my 32 numbers, I can do 30 minus 8 to get that 22. So we might see that here or there in some other problems where it'll be a little bit easier to kind of think that way. Instead of finding what I'm looking for, it might just be simpler to count what I'm going to leave out and then just do a little subtraction to figure out how many there actually are. But either way, you'll get 22 out of 30. So basically, that's kind of what I want you to do here with probability. You have 2 questions to do today for probability on the next page. Again, sorry about the weird flipping on your packets. But number 1 has some things in common with both of the 2 example problems. Number 1, you're going to roll, it says number cube. They'll never use the word dice on the keystone, but if they're talking about number cubes, they're just talking about rolling dice. So you've got the numbers 1 through 6 on dice. It's going to be a very similar table to the one we did in number 2, example 2, but you are allowed to get the same number twice when we work with dice. There's nothing wrong with getting 2 1s on 2 different dice. That will work. So your table will not be exactly the same as it was in example 2, but it will be very similar. As a matter of fact, you should draw one that looks similar to the second table because the questions are going to ask you about sums. And then number 2, this one's going to be a little bit like, again, like the same things. We're not doing things with numbers, so you're going to be writing letters here. So we're going to be writing letters. But you have to read it and understand which letters to draw. But we are going to be in the situation here where we don't pick the same thing twice. So you are going to have the X's in your table like you did in example 2. So what you should do is you should start with these 2 problems. If you are all caught up with the rest of your work, when you're done with those 2 problems, go on to the last page. I want you to do a couple things here. I want you to solve these problems by hand. And then when you're done, I also want you to check them in Desmos. If you are missing a couple things, if you were out multiple days last week, on the other hand, don't do these problems. Get one of the packets that you're missing and get that finished before you try to do any of these problems. So these problems are for people who are caught up. If you are not caught up, I need you to get the stuff finished from last week. But either way, everybody should have something to work on. If you are working on these, when you're done, make sure you drop them in Desmos to make sure they are correct. If you hand me this paper with wrong answers, because you didn't check them in Desmos, I am going to give the paper back to you without grading it and tell you to figure them out. So that is a big part if you are doing this today. Okay, with that being said, I think you should be ready to get to work.